let's start with changeover in itself and put a little reminder on changeover. Changeover, we can use it in hydronics for quite a number of different purposes. It can be most important application, I would say, the heating and cooling, rather most important, most frequent application. But we could have a changeover with a high and a low regime. That has been the case, for instance, in a setup of a sports center, where they had a high occupancy and then a low occupancy of the sports center, and they wanted to have two different regimes. It can be obviously day and night. It can be week and weekends. It can be different types of application where you are toggling between two different states. Of course, you could have more than two different states, but then you are entering a much more complex behavior, and you need to prepare for the control system that goes along. By far, as it is clear for us, the most usual changeover that we meet in application is the heating cooling one. But we have also met other applications with TS Slider, and it is for this reason that you will see the implementation for TS Smart is a little bit different and has been made a little bit more general than what it was done with Slider initially. Heating cooling changeover, just to fix the minds, two pipe system here illustrated as it is in heating mode. You get a two-pipe system globally delivering to a number of units, and at some point you are switching between a boiler and a chiller. So you are globally in the system in heating mode or globally in cooling mode. And at one moment in time, there is a decision that is taken. It will be typically at spring you go to cooling, and at fall you go back to heating. It isn't flexible, it's global switching, and it is usually made in this way for cost reasons. There are also in this kind of setup usually a limited number of controls available to make the switching of the device to simply control the changeover in itself. And therefore, an automatic changeover by the device itself is quite desirable. We are going to look a little bit into that. Then we have a four-pipe system with individual changeover, and nowadays, in most cases, on terminal units, we would speak about a six-way valve. So we get a flexible changeover by unit or by group of units. Even when using six-way valve in office typical applications, you would have one six-way valve for a group of radiant ceilings, for instance. So it's not necessary for one module at a time, it can be for a little group of them. You would have a PLC with dual range signals or a bus system available to be able, of course, to control individually these different units. And therefore, you need to have the capability from the device to adapt itself to the chosen switching system. So this is a little bit what we have in front of us. You know that for changeover solution for small terminal units, our solution that we propose nowadays is the six-way valve with a TA M106CO and a TA modulator with a TA slider 160CO. That is not changing, and the TS Smart in itself is not coming to propose an alternative to that, because, well, the TS Smart is not precisely the valve that is made to be installed on the small terminal units. You would install it maybe on smaller handling units, but maybe given its cost, not yet on each and every terminal units. This being said, let's look directly into the configuration of TS Smart for changeover with iTune. Well, we get directly into the configuration menu, and in the configuration menu, we will go to, and I'm sorry I didn't click on the right one, but on control setting, you would click and you would obtain the control settings screen here. And in this control settings screen, you see there was already that available at previous webinar, a changeover line, which is only available if the firmware of your TS-Smart is a 4 dot something. And if it is a 4 dot something, then you are able to enter the screen. If you don't have a TS-Smart updated to 4 dot something and you try to touch this line, the app iTunes will tell you, sorry, but you need first to update your TS-Smart before you can access this functionality. So let's assume that we are touching this line and we are now arriving to the changeover screen, which by default is pretty simple. You have one option, regime switching, that by default is set to none, so meaning there is no regime switching by default. It makes sense. Okay, if you touch this line, you then enter in a screen that will propose you different options. Of course, the none option, but then three other possibilities. Dual range input signal can be one way to make the switching. Bus can be another way to make the switching. And then something totally new, which is temperature detection. So we have three possibilities, and there is a fourth one that will come later, and which is all about scheduling, whereby through a calendar, the people will be able to schedule the fact that, for instance, on the third Sunday of September, the switching should be made to heating or things similar like this. So this is the very first thing. The initialization of setting up changeover happens in a little bit different way than what you are used to with TS-Slider, where you have to basically decide to associate an action to the binary input, or you have to switch by yourself to an input signal that is dual range. Here you really select the type of regime switching. So let's see what it means to configure each of these ones, but first get a little bit more details about what it means in the TS-Smart. So dual range signals in TS-Smart, they are very much the same as the ones that we have got in TS-Slider, with one exception. It's that we have got milliamperes dual range signals that have been added to TS-Smart, since TS-Smart has got milliampere analog input. So typically a dual range input signal is like this. We are exploiting, if I am taking the 0-10 volt type of signal, we are exploiting the full 10 volt that we divide in three areas. The first area is the regime 1 area in red, where we are going to do proportional control according to the chosen characteristics. If we are in flow control with TS-Smart, we will get an equal percentage characteristic like this. At 4.5 volt, the valve is shut, and at 0 volt, the valve should reach the max flow that is set for regime 1. Of course, here, the valve will not necessarily give you 0 flow or be shut, because you might have defined a minimum flow that is not 0. So here we are simply applying the opening and closing of the actuator according to the corresponding control mode. You get a second area, which is regime 2, where we do exactly the same as for regime 1, but according to different maximum and minimum value. And the fact that regime 1 is on the low voltage and regime 2 is on the high voltage, it's only starting a default situation. You will see that in the input signal screen, you are able to reverse this assignment of regimes, because it might very well be that the people have programmed their controller in the opposite way, and therefore we need to adapt, and the quickest is simply to go in the app and switch between regime 1 and regime 2, so associate regime 1 to the high voltage and regime 2 to the low voltage. And of course, in between these two, we get a neutral area where the TS-Smart is fully shut, but only if the minimum flow is different, is not different, is different from 0. So we are getting this use of the dual range, nothing really new except that, you will get a characteristic associated to the control mode that you have chosen. A dual range signal is advantageous is that with only one wire, one line, we are able to pass two types of information, how to control the device and in which regime we are. We have proportional voltage or milliampere signal as used by controllers for 6-way valves, so nothing really new. I mean, STSmart can be connected in just to the same controllers as you would control basically a 6-way valve or a setup like we have with the slider CO. And simply STSmart will interpret the voltage or the milliampere value to toggle itself between regime 1 or regime 2. The available dual range signals for STSmart are by default this one, the 0, 4.5, 5.5, 10. Forgot to mention, but the fact that we have a neutral area, it is important. This is to avoid that at some moment in the year, the valve would constantly switch between heating and cooling and would therefore create a switching in the system that would not be very good thing for the people that are dealing with the control system. And if associated actions are programmed in the system, you could simply get an issue with the wearing of the associated equipment, be them relays or whatever. We get then the simply input line broken variant of this signal. This is the 2 volt, 5.5 volt, 6.5, 10. We get then the first one that we had, which is the one that has been simply taken over from 6-way valve, because 6-way valve needs to get the range divided in 3 perfect thirds. You are forced to use only 3.3 volts for each range. We have proposed this new variant because then we have 4.5 volts, which is already better than only 3.3. So you get the input line broken variant of the same. And then you get 2 signals, which are the pending one corresponding to these ones in voltage, but in milliampere, the 09, 11, 20, and the 4, 11, 13, 20 in milliamperes. So this is what we get in terms of dual range signals. In terms of bus changeover with STSmart, there are quite a few registers that are related to that because, as you might have already seen in the list of registers, they are tagged with regime 1, regime 2, because we get all the max flows, max values, max power, max position, etc., that can be assigned each for regime 1 and for regime 2, clearly. And therefore, we have already a lot of these in the list of Modbus and registers. But the 2 most important comments for the changeover by itself is the definition of the regime switching. So define if the regime switching is 0, none, 1 dual range, 2 bus, 3 temperature detection, 4 scheduling is not yet implemented. And then you get another register, which is this time not one that is read-only. This one is read-only. You need to set it up with iTunes because you have a lot of parameters to set with the app, and that would be much too difficult to do that entire by the bus. So you do this only once. But then switching between the regime is done through the register current regime, where you can set the current regime to a value of 0 or 1, regime 1 or regime 2. And then there are 2 additional ones that we will use later on. So about at the same time we'll come with the scheduling, we will introduce something more, which is the setback on the regime 1 and 2. And imagine that we are in heating and cooling. The setback that will come will be a way by scheduling to define that at a certain time of the day, you want that the valve applies to itself only a fraction of its maximum flow. For instance, you could take a setback at 80% or at 70% or at 50% of the normal max flow. And that could be a way to decrease simply the heating and cooling overnight, for instance, through the power control, or possibly you may prefer through the flow control. In BACnet is exactly the same, except that these are not registers, but objects. And you get register 200 and 201. Here you get MSV 11 and 12, so multi-state value 11 and 12 for the BACnet objects. Okay, the next one is something really new for us in terms of changeover, and I think for quite a few other manufacturers. I've not seen many things like this, but when you think about it, TSmart is aware of the supply temperature at any moment in time, the supply water temperature, naturally. Okay, and this is the case provided, of course, that you have properly set the installation side of TSmart. So if TSmart is installed on the supply like this, then the valve knows that the remote temperature sensor is on the return. Then the valve knows that the supply is the local one, and we can therefore really know which one we have to look at in terms of supply. Then, depending if the supply is colder than the return or warmer than the return, then we are able to detect whether we are in heating or in cooling. And actually, we are not going to work in temperature detection by looking at the difference between the supply and the return, because the flow could be quite small, and therefore the two temperatures could be very, very close, if not equal. So what we are doing is to provide a system by which TSLider is monitoring the supply temperature, and if the supply temperature is above a heating switching temperature, then the TSmart consider it is in heating and will assign to itself the max flow of heating. Of course, temperature detection does only make sense for heating cooling. For day night or for high-low, it doesn't make sense. If you stay in heating all the time, you cannot use temperature detection, and you will see that this is taken into account in the configuration in the app. Reciprocally, when the supply temperature is colder than the cooling switching temperature, then the TSmart switches to cooling and therefore assigns the max flow that has been defined for cooling. If the TSmart had its supply temperature, for instance, at 6 degrees below the switching temperature of 19 degrees, for instance, it is in cooling, and then you stop the installation, you shut the valve. So the water, including the supply water, starts to warm up. And maybe at a certain time, this water on the supply here will become larger than the switching temperature. Well, actually nothing will happen. It will stay in cooling. And it's only when this temperature starts to increase that then the valve will consider, the water is definitely warmer. I am now in heating. So I know what a few amongst you might be thinking about. You say, yeah, but when the valve is shut, if I am changing the system, the valve will not know that I am now in heating until it is open. Well, does it matter? Not really, because what is happening if the valve still believes that it is in cooling while you are in heating? Well, its maximum is different. If the system defines that the valve needs to open itself to propose some more heating, then it will open initially with the wrong maximum value, but when it is opening and it has not yet reached the maximum value, the flow starts to establish itself, the supply temperature will quickly increase, and then the valve will switch correctly to the heating and continue its control according to the correct maximum value. So there is only a little transition in time where we might be in a situation of when the valve is closed and the switching has been made, we have changed the way we warm up either or cool down the water. It's only in these few moments that we are going to be in a situation of not being exactly as the system is set up at the defined moment. So this is it for the main principle of this switching systems. If I am entering now the changeover screen and I look at the dual range case, when I have selected dual range, you see that I have a first option that is asked, and this option is called regime naming. Might be changed in English name to changeover type. This is where you are saying, well, actually, I am doing a changeover between heating and cooling, or I am doing a changeover between a high and a low regime. And then we have put a generic one, which is regime 1, regime 2. We could add, it's only a way to name the system so that the user interface looks better. This is because with TA slider and changeover, we had heating, cooling, but if you want to use it for something else than heating, cooling, then you get a display that is a little bit odd, isn't it? The only way and place where this really matters, this is when you go to temperature detection, you only can get in heating, cooling, because, well, of course, if you detect on the supply water temperature, you necessarily need to have a switching between the heating and cooling mode. I can now go into the first of the parameters, the input signal range. I have, of course, the control limits and the temperature limitation that we will look at later. Input signal range, I come here. As soon as I am in dual range, I will be jumped to the type of control, which is proportional dual range. As before, I can choose my input signal range according to a type, to a direction, direct or reverse, and then amongst the list with and without basically the input line broken detection. Then I have an important one, which is the changeover regime assignment. You tap here on the little badge with the double arrow to invert the assignation, the assignment of the regime to the low and the high voltage region. And you will be able to practice that when you touch this. Heating will go to the right side, cooling to the left side, and the color of the two curves will change so that you get a good visual match. Basically, what will happen into the TA Smart is that when you will be in the low voltage and you have reverted, then this is the cooling limits that will apply in this area, and the heating values that will apply in this higher voltage area. Again, here, the reason for doing this is simply that before it is implemented, you cannot precisely know how they have programmed their controller, and there is therefore 50-50 chance that they have done exactly the opposite as what is our default, and we need therefore to be able to invert this. If you do the configuration of changeover with bus system, the first thing, if you have not activated your bus first, is that iTunes will tell you, I'm sorry, but your bus communication is currently disabled, and you need first to go to the bus communication screen and activate the bus, enable the bus system to allow then using the bus for switching between the changeover regimes. Makes sense. We force the people to go to the bus screen because it's not just choosing about Modbus RTU on BACnet. As you know, you need to specify an address and a few parameters to make the bus communication work. So we invite rather the people to go themselves to the bus screen, set up their bus properly, and then come back to changeover to assign then a changeover by bus. Once you have activated, enabled your bus, one bus protocol has been chosen, and the one that currently is activated applies. You have, of course, access to the four usual ones that we have, which are Modbus RTU, Modbus TCP, BACnet MSTP, and BACnet IP. The next case is about the configuration of changeover in the case where we want to use the temperature detection. If you choose temperature detection, you are now first getting the changeover type of the regime naming, which is fixed to heating cooling. As you can see here, we are showing it in an abbreviated way because we don't have so much space, and depending on how it is translated, we would not have enough space in all languages, so we make it abbreviated. But when you tap here, you get the full name and you can get a clear idea of what it is. The switching temperature have to be defined according to the application and the conditions of use. The default values, I have set them like this, 25 degrees for heating. So I need the water to be warmer than 25 degrees to decide that I am in heating. I need the water to be lower than 19 degrees to decide that I am in cooling. Why so high switching? Or simply to be generic enough. If you do cooling ceilings, you might have a 16, 18, even a 17, 19 degrees type of regime. And therefore we have to be a little bit careful with that. Obviously, you can change this value to adapt them to the situation of use in the application. And we could also absolutely adapt this variable to your local areas in iTunes. We have in the database of iTunes the possibility for your own region. So it could be, one of those areas that we are defining in iTunes and that you select after first installation of iTunes. We can associate different values. So if you have a specific requirement for the switching temperatures, well, please contact me. We can talk about it and we could adjust these values. If I am touching this line, I will then get into the switching temperature screen and I get a very clear interface telling me in heating, the heating switching temperature is 25 degrees. And I get an explanation where it says that this first switching temperature is the temperature of supply water above which the TSMAR will switch to the regime defined as heating. And then the same for the regime defined as cooling, except that this is the temperature below which the TSMAR will switch to cooling. Again, here is the idea as I have explained a little bit before. We get two switching temperature. The water needs to be above that value to go into heating, then it is in heating. If it is cooling down at some moment, it stays in heating, and it's only when the temperature goes below the switching temperature of cooling, then that it says that it is cooling. One good thing to remember, but you will see that because the app will not allow you to do anything else than that, you need to have a minimum of 2 kelvins of difference between the two switching temperatures. And this is to avoid any erratic switching that could happen over time. If you are in mid-season, you would not like that the valve constantly make a switch, even if it is only in the logic of the valve because it's not operating, it's in between. It's never good to get the system constantly switching from one to another because you never know what can be related in terms of reading the current regime by bus and then doing a specific action that could induce some trouble in the rest of the control system. In terms of control limits and temperature detection, well, it's not very difficult. We just duplicated the possibilities of input. You get the control limits in heating with a max flow and a min flow, visualized here. And then you get the control limits in cooling with a max flow and a min flow. Well, here, typically, I have a max flow for cooling that is larger than in heating. It's quite common, right? You can clearly see that visually over there. For temperature limitation, here I've taken a screen capture for delta T. You get a delta T set point that by default is set for something more realistic for heating and something more realistic for cooling. And then the minimum flow threshold is the same ratio, is the same ID, so it is 25% by default of the maximum flow currently set. So 2000 makes 500 liters per hour, 3200 makes 800 liters per hour. It makes just sense like that. Nothing has changed. It is just the fact that when the valve will be in heating, then this min flow and max flow will apply, and this delta T set point and minimum flow threshold will apply. And when the valve switches to cooling, then these are the bottom ones that will apply. Finally, the way you can look at it and observe that you are in changeover, you will see in the live screen one more field, which is located here. The current regime is displayed in abbreviated format, again, for the question of the lack of space, because if you are in TSMART-DP, and TSMART-DP has a changeover as well for two different delta P set points, we need to get enough space to display the delta P here, so we have to be mindful about the space. And this is why it's abbreviated, but you see R1 for regime 1. And if you are in dual range, which is quite the probably most common ways to do the changeover, you can see as well that you're in dual range by the type of the signal that is displayed in this way here. I remind you of something that I said earlier. You only get changeover in TSMART if the TSMART firmware comes with a version 4.0.0 or later than that. Okay, well, as I told you, it's a little bit faster today because changeover is not really rocket science in terms of principle, but as I told you, given the number of possibilities and parameters, you will have plenty of time during the practice at the conference to play around these different possibilities and see how the valve is switching between the different regimes. All right, so on this, I am open to any questions you would have during commission. So Jose, yeah, advice, yeah, well, the advice for updating the valve, we will do that definitely in any manner for any functionality. It's already the case for some other functionalities that have been introduced later. When you have an iTunes app that contains these functionalities, an iTunes app is able to read the firmware of the valve and realize that, oh, the firmware is a bit older here. If you try to use a functionality, iTunes will tell you, to make use of this functionality, you will need to make an update. So that's not just for changeover, that's like that for other functionalities. Conrad, now during commissioning without water parameter, is possible changeover mode test according to input signal? Well, yeah, well, you know, you go to the changeover screen, you put yourself in changeover input signal, and you play with the voltage to check a little bit how it is switching. That's absolutely no problem. One of the other ways, simply, Conrad, if you want to make the switching, you leave the things to the right temperature, you bring a glass of cold water, you take the sensor out of its temperature pocket, you warm it up, you cool it down, and you verify that the valve is switching. That's another way to do. Could you explain what the setback is referred to? Yes, Maurizio, the setback is one thing that we were thinking that we might bring it here at the conference, but it's something that requires quite some more job. Basically, it's after some discussion with customers. In some cases, they get a heating cooling changeover. That was all nice. But heating cooling is to change yourself from, say, winter to summer conditions. And in mid-season, some parts of the building, if you do individual changeover, will be in heating and some parts will be in cooling. Yet we had an application where a customer came and said, yeah, well, it's all nice, but me, I also have, and I don't have that in my system, but it would be great if I could actually assign a period of time where it would still be in heating, but I could be a little bit down in heating to save. So I say, okay, this is like a setback. Yeah, exactly, etc. So we've been thinking about that. the team has developed a calendar system into the firmware of TSMart. This is what we have to continue to validate and to refine, and to implement the corresponding user interface in iTunes, where you are going to be able to simply say, all right, I want to define a possible setback for the heating regime, and I want that on the Monday at 10 o'clock, I go to 80% of the flow or 80% of the power. And at 7 o'clock in the morning, it goes back to the full regime. And you will get 4 periods of possible different set points defined over each of the 7 days of a week. So that is what it is going to provide you, meaning that you could be then not just in regime 1, you could be in setback of regime 1. It's a supplementary way, refinement simply to the changeover. You don't have to add a setback. It will simply be a switch in the changeover screen where you will say setback on regime 1, and it will be disabled by default. If you enable, you will enter a screen and you will define a scheduling for your setback. So that's the general principle that will come on this setback.
It's really, thank you. It's really clear. The problem is that I don't know how to translate it in Italian. Yeah, can I say that is a sort of?
I got the same question from Mikko from Finland. It's not easy because I had to say in French there is also nothing like setback. In French, this is translated as ralenti, so slow down.
Slow down, exactly. I saw your translation. And of course it will be a sort of reduce power or flow.
Exactly. That will apply as a ratio applied to the maximum you have defined for the full regime.
Yeah. And can you also define in terms of percentage the amount of this reduction, or is just by default you said I will be at 80% of my?
No. You will be able completely to define your percentage.
Yes. Okay. So the percentage and the scheduling.
The percentage will be, you can change it according to the time. So I told you that you will have 4 periods for each of the 7 days, and each period can have a different percentage. So you could say that.
Wow, it's really a schedule.
Yeah, well, I mean, if we do it, we try to stick to something that could be usable. Okay, we have to draw a line somewhere, because we could do an annual calendar, but then that becomes madness to, well, I mean, to program and to maintain. So we try to bring some flexibility and usability of the system, and with this, I think we have a good balance.
Okay, thank you.
You're welcome. Okay, anything else?
I've just a thought on with the setback, where we can define what happens over each of the 7 days. Will there be a register entry in the bus that will say enable setback regime or disable setback regime? Because I'm just wondering from a point of view of, if we're looking at setback and you take, for example, setting back the heating when we're coming into winter. So in October, we would want to run setback. In November, we'd want to run setback. December, January, February, you might not want to run your setback. But obviously that then becomes super complicated in terms of the TA Smart. Is there a register entry that says turn it on or turn it off effectively?
I have to double check that, but I don't think so for the moment. Everything is possible. For the moment, we have this current regime where you are writing with the bus. You're saying current regime is this. This is the way you do. Current regime is heating, or current regime is cooling, for regime 1 or regime 2. and basically then you get it associated. And then if you say current regime is set back, then you will get that. We need to work a little bit on this because we have to make the bus work with the calendar, so things will change a little bit. So it's actually a good point that you raise up to us. We'll take that into account.